CPM Math 3, problem 1-42, and we are being asked to graph a function with a variable in the denominator, so g of x equals 2 divided by x. And in order to set up a table, truly, we just pick a bunch of x values and plug them in. Excuse me, better word would be substitute, and we just substitute in order to get the appropriate y values. So that's all that's happened here, and that work should be shown on your paper. When you graph it and when you plot this, you get a graph that looks sort of like this. Super interesting. The shape of the graph, how would we describe that graph? Well, we would simply describe it as nonlinear at the very least. That's what we're looking for, nonlinear. We could also describe it as two increasing and decreasing curves that are in the second quadrant and in the third quadrant. Wait. First quadrant and in the third quadrant, excuse me. All right, this is a continuous graph because it is connected. There are not like discrete points or dots on the graph. The domain, if you notice that 0 yielded us an undefined output, that means that 0 is not in the domain. You cannot use it for an x value because you cannot divide by 0. Okay, so we would say that the domain is all real numbers except x cannot be 0. And that's what we would say for the domain. The range is the same thing, okay? All real numbers except y cannot be 0. Notice how there is no 0 where our graph is ever going to touch, okay? It is symmetrical, and technically it is symmetrical across the line y equals negative x. All right, so if you kind of drew that little line in, you notice that it reflects across. It's reflection symmetry. There are no x-intercepts or y-intercepts, which is kind of interesting about this graph. It is a function because it passes that vertical line test. And the asymptotes are, this is an asymptote right here because this will approach, but it'll never actually touch it. And right here, this will approach, and it'll never touch it. All right, so x equals 0, or excuse me, and y equals 0. All right, here's the y equals 0. This is an asymptote here as well because this will approach and never touch, and this will approach but never touch. So our asymptotes, we do have two, x equals 0 and y equals 0.